Bismillahirrahmanirrahim. Exercise 3.4, question number 1, part 21. Integral of x sine inverse x divided by square root of 1 minus x square into dx. The formula for integration by parts, integral fx dx, considering f as first and g as second function, equals to fx constant, integral of gx dx minus integral derivative of f into the same integral of gx, and then we close the bracket and we have dx for this integral sign. The results which we must know for evaluating this integral are that we must know the derivative of sine inverse x equals to 1 by square root of 1 minus x square. And we must know that if we have to integrate a function and such that we are given a function whose power is n, and we have its derivative with it, that is we have f of x to power n into f dash x, function to power n and its derivative here. Then we can integrate it with the help of power formula, which is known as f of x to power n plus 1 divided by n plus 1 plus a constant of integration. Then we must know that d by dx of 1 minus x square is equal to minus 2x. Let's get to our integral. Integral I equals, we have named the integral as I. Integral I is equal to integral x sine inverse x divided by square root of 1 minus x square dx. What do we do here? We just arrange it a little bit and we write it like this: integral sine inverse x into x divided by square root of 1 minus x square. That is, we arrange it a little bit. Now, what we are going to do, we are going to write the formula of integration by parts once again in the solution. I'm going to write the formula for integration by parts. The formula for integration by parts is integral f of x, g of x, dx is equal to first function constant, that is fx as it is, into integral of g of x dx minus integral bracket the derivative of fx into the same integral gx dx bracket close, and we have dx. We wrote this formula and we name it as 1. And now what we are going to do, we are going to specify the functions. Let f of x equals to sine inverse x. So what do we need? We need fx and we need f dash x. So we are going to evaluate f dash x from it. It tells us f dash x is equal to derivative of sine inverse x. We have discussed it here. It is equal to 1 by square root of 1 minus x square. Let g of x is equal to x by square root of 1 minus x square. Then what do we need? We need integral of gx dx both times. So we are going to evaluate integral of gx dx. So integral of g of x dx, it becomes integral of x divided by square root of 1 minus x square dx. Now get to this result. What is this result? That we have a function to power n, its derivative is there, then we can perform integration. So what we are going to do, we are going to write it like this. It is equal to 1 minus x square to power minus 1 by 2 into x and a dx. What happens here? I wrote this square root as power 1 by 2, and when I bring it to the numerator, it becomes power minus 1 by 2. Now you can see in place of function, you have 1 minus x square. In place of n, you have minus 1 by 2. And in place of f dash, we have x. What is the derivative of 1 minus x square? The derivative of 1 minus x square is minus 2x. It means we need a minus 2 here. So what we are going to do? We are going to multiply and divide by a minus 2. We will multiply minus 2 inside the integral and we will divide minus 2 outside the integral. I'm going to do it in the same step because we have discussed it. So let me do it here. I'm going to divide by minus 2. This is division by minus 2, and I'm going to multiply by minus 2. So minus 2 here, and I better use a bracket. Now you can see what happened here. The formula for integration is ready now. I have got the function as 1 minus x square, the power n as minus 1 by 2, and f dash is minus 2x. Now what I will get? I will get f of x, that is 1 minus x square to power n plus 1. What will be n plus 1? Minus 1 by 2 plus 1, that is 1 by 2. I will have 1 minus x square to power 1 by 2 divided by 1 by 2 plus c. So let me write it. The result becomes minus 1 by 2 outside, and here I have 1 minus x square to power 1 by 2 divided by 1 by 2. This is it. And of course, a constant of integration. So let's write it there. So what happens? I see that I can cancel this 1 by 2. So I cancel this 1 by 2. I cancel this 1 by 2. And as a result, what do I have? I have integral of gx dx is equal to minus into square root of 1 minus x to square to power 1 by 2 can be written as square root of 1 minus x square. I like to write it in this shape. Okay, so this is the integral of gx dx. Now I have all the values. Now what I'm going to do, I'm going to put all these in one. Put in one, in the whole one. Okay, from on the left hand side, in the right hand side. And let's start writing from left hand side. From left hand side, I have integral. In place of fx, I will put sine inverse x. In place of gx, I will put x by square root of 1 minus x square. In place of dx, I have just dx. And then what happened to my square? Let me correct it. Okay, now it's good. And then I have the right hand side equals to, what is the value of f of x? F of x is equal to sine inverse x. Integral of gx dx is minus square root of 1 minus x square, and then minus integral, what is f dash x? F dash x is 1 by square root of 1 minus x square. What is integral gx dx? It is minus square root of 1 minus x square, and then I have a dx. Just put all these 1, 2, 3, 4, 5, and 6, all these 6 values in it. And now you can cancel whatever got cancelled. So let me start with nothing cancelled, nothing cancelled. And what happened here? This got cancelled. Okay. And what will happen? This minus will come outside and make this sign plus, and this minus will come here. Let's write the result now. Let's go for it. What do I have? I rearrange it as integral x sine inverse x divided by square root of 1 minus x here. I write this x here into dx is equal to, this can be written as minus square root of 1 minus x square sine inverse x. Then minus and minus become plus. And what do I have? Integral dx. Perform this integration, and what you will get? You are going to get minus into square root of 1 minus x square into sine inverse x plus x and plus c. Integral of dx is equal to, you may write it here, otherwise it is a very simple and basic result. It is equal to x plus c. So I wrote it in here. If you want to adjust your answer, if you don't like to start your answer with the negative sign, as I don't like to start my answer with the negative sign, so I am going to rewrite it as x minus square root of 1 minus x square into sine inverse x plus a constant of integration, and that completes the answer.